So when you get tired of how long Old Pochmann takes to blind solve a Rubik's Cube, you may want to consider changing your edges into the method M2. It is faster, it uses the same idea as Old Pochmann, and there's not very much of a learning curve. It's very similar. It was also developed by Stefan Pochmann, and he made it to replace Old Pochmann, which is the method that you would know by now. For Old Pochmann, you would shoot the buffer piece UR into the UL position with the T-perm. In M2, it's very much faster. You shoot the DF piece into the UB position with M2. It's as easy as that. You have the same idea as Old Pochmann, where you do setup moves. Like, for example, if you had the FR piece in the buffer position, you would do setup move to put R or FR into the receiving position, do M2, and undo the setup moves. But using M2 as your swapping algorithm has some obvious downsides. Each time you do M2, you don't not only swap these two pieces, but you also swap the centers and these two pieces. Most of the time, since you're just doing it over and over again, it won't be a problem. However, when you get a position like this, where one of those centers is in the middle section, you need a couple of algorithms to handle it. For example, when you have the UF piece in the DF position, you do U2 M prime, U2 M prime. And it's just the opposite when you have the DB piece in the DF position. M U2 M U2. And obviously if you have the UB piece in the buffer position, you just do an M2. And that works half of the time. However, if you have one of those positions after you've done an odd number of M2s, then you may have the DB piece in the DF position. But when you do that move, you can clearly see that it's in the wrong place. So when you're using M2 to solve the edges, when you have one of the center edges in your memorization, you have to think about, have I done an odd number of M2s? And if you have, then you shoot to the opposite position. So here you would shoot to UF instead of DB, and it's permuted correctly. Something that will also come up quite often is you will have a situation where DF will go to BD or something like that, where if you do the permutation algorithm, these two pieces will be flipped. And that's exactly what you want to do, because there are algorithms that will flip these two and permute them. I believe this one actually is that. But the algorithms are very awkward, and it's much faster to permute them like they are, and then at the end, do an omega snap to fix them. But then you come into the issue of memorization, because when you permute this piece to right here, then that does not return to your buffer position. This does. And so, when you're memorizing, you have to realize that if this piece is flipped, you will be moving the piece to D, or you'll be moving the piece to BD, but the DB piece will be moving here. Like that.